I want to spend some time talking a little more about the theory behind formwork. And so we'll go over these set of slides. I've posted the slides on the on our course link, and also I have a PDF of the material that corresponds with this. So I encourage you to download the PDF and take a look at that. I think by the end of the lesson, you want to be able to do a couple things. We've already talked about several of them, but the formwork we're talking about is considered temporary structures. So we want to be able to understand that and how important they are. We've talked a bit about wood and plywood, but again, we want to re-emphasize that since that's what most forms are made of. We want to look at the design considerations for concrete formwork. We want to talk a little bit about failure, and we want to look at the components again. We've already been doing that, but we'll keep going over it until we're done. And we want to look briefly at calculating loads on concrete formwork and then designing wall forms. So again, this all ties together. This theory is, I think you need this background, but for most of the calculations, again, we'll be using the programs I've given you. You'll see that in terms of this material and the material in the handout, is a set of notations so that you can understand what the symbology is that we're talking about. So we're going to talk about concrete formwork construction, scaffolding, falsework shoring, cofferdams, underpinnings, diaphragm, slurry walls, earth retaining structures, and construction dewatering. And what do these all have in common? They're all temporary structures. You're going to use these structures, you're going to build these in order to get the final product built. Generally, you'll remove them when you're done and you've got the final product. In some special cases, especially with some bridge decking, underpinnings, things like that, you will leave them in place. But they're not load bearing anymore. The structure itself takes the load. So temporary structure is any means or methods that we're going to give temporary support so that we can get a job. And they're needed because you just can't build a lot of things without forming them. And that's the case, especially when we're working with concrete. You need something to hold the concrete in place until it hydrates and becomes solid and can carry its own weight. And temporary structures, and we've talked a bit about this, but they affect all aspects of the project. The schedule, the costs, the quality of the work that's going on, even the quantity of work that's going on. You need to have temporary structures that you can move, reuse, apply, take down, disassemble, and move along. So the better you can do that, the more efficient your structures are, your temporary structures, the easier you can move along. We've been talking about safety, and again, I think if nothing else you leave from the course is that when you're dealing with equipment, when you're dealing with forms, things we've been talking about this semester, safety is the most important thing. And you'll find that, especially when it comes to temporary structures, you find a lot of problems, a lot of safety issues. And so you have to be able to do this right. And what I've indicated to you before again is that you're not going to be a detailed designer, but I think you need to know enough to be able to check designs that your contractor is going to give you or you're going to get from a structural engineer. So the bottom line is, no matter what's going on, safety should be the #1 priority. No matter how fast you think you can move things, moving things fast, quickly, isn't necessarily safe. Generally, the responsibility for the structure is temporary structures anyway, is that of the general contractor. But again, like I just mentioned, you need to, I think, know how to go about doing forms. You need to be able to know how to check them to make sure that they're being done right, correctly, that they are going to be safe, that construction speed isn't sacrificing safety. So that's your job when you do this. So what are we going to consider when we are looking at the design of a temporary structure? And safety, and you can't beat that when too much to death. It's most important. Cost. You want to design cost-effective solutions. And we've already hinted to part of that cost effectiveness, but it's kind of wood. How many times you reuse wood if you're doing wood forms. How many carpenters you need, how busy you can keep them, the kind of tools that you need to have on the job site. So cost is important. Things you can affect already from what we've already talked about. There are some unique design challenges. Again, especially when you're talking concrete formwork, loading isn't equal. When you're working on the forms with a crew of people, you're vibrating, you have wet concrete that you're moving around and placing. Loading isn't nice and uniform. And so when you're looking at the design, you have to consider these dynamic loads, impact loads from things being dropped or bumped, just dumping of concrete, a change position. So all of these things impact and have to be considered when we're doing our design. And again, there's always the unforeseen. Hopefully you've taken steps to check for a number of these, especially soil conditions. And also you're going to be talking about what kind of factor of safety you're going to be using for the work that you're going to be designing and doing. Generally, the contractor is the only one on the site that has practical knowledge of the structures. They're generally going to have their own engineer or hire an engineer to do this kind of design. And likewise, if you're the owner, you're going to need to be able to have somebody on staff or hire somebody to check in detail calculations. Again, what you want to be able to do is understand where these structures are coming from at this point in time, and to be able to see if they're in the right ballpark. Often when you have complex structures, use a design build basis. So what that really means is you hire a contractor or form builder, and they design it and they put it up for you, design build, and then they take it down, you are done, and move things around. So obviously if you get someone like this, they're going to be a specialist. You're probably going to get optimal form design, cheapest price. Although again, it's not saying it's going to be cheap, but in terms of the overall project, they're probably going to be the most economical for you because there's a lot less risk. Things can just progress a lot better. So again, we've already talked about, you need to be able to understand what these contractors are thinking about, just so we can keep things safe and productive on the site. And this is a structural design, so we have to look at all the structural members, and that's what we've started doing already. Remember, we've been looking at the names of the different pieces of the forms, and again, the structural engineer is going to be responsible for the design, and they're going to make sure that they're safe and that they can be reused if possible, that they're going to give the proper service. In other words, give a good final quality final product, again, for the most economical cost. Right? We don't want, if you're doing concrete walls or floors, you don't want sags in them or bumps in them, bulges. They should be true and flat, and the dimensions should meet the requirements of the design. Like most work that we do, you'd want to be able to do several designs, compare the costs, and when you're doing this, you're going to vary the designs, or you have to consider a number of designs, just like most structural design work. Dead loads, live loads, wind loads, earthquake loads, and earthquake loads, remember, aren't just for places like California anymore. Even out here in Missouri, we have to worry about earthquake loads, so that's important, just like we have to worry about snow loads. And there's all other types of loads out there, hydrostatic pressure and soil pressure that we have to consider. There are design specifications, American Concrete Institute, and there are building code, or ACI, American Concrete Institute, their building code requirements. So you have to check which building code is being used in a locality that you're working in, and then make sure you get the right code to be able to find any special requirements. We've already been looking at wood, and there are specifications by American Forest and Paper Association and a lot of other wood places. So those are one of the things you're going to have to check on too. As concrete work has expanded through the century, and again, reinforced concrete work only got started in the late 1800s. So we've got 150 years of design work with large concrete structures, and I'm talking reinforced concrete building structures, okay? And so as concrete work has expanded, so is the formwork development and how we go about doing formwork. Again, we've looked at figure 1, a typical concrete wall formwork setup, and so again, just a reminder about the some of the major components. In this case, this figure is emphasizing the ties that are holding things together. And you see, like I said, only 100 years or so, in this case, just over 100 years, that steel forms were first used. And we're emphasizing wood, again, remember, in our design here, but steel is a good alternative, especially for linear work like concrete paving, sidewalks, floors, things like that, where you have real consistency. And sidewalks are 4 inches. Pavements are 8 inches or 12 inches. So you have a guarantee that you're going to, if you have a certain size form, you're going to be able to reuse it over and over again. And they're modular, and they're easy to pick up and move around. And again, the biggest problem is some weight. But again, with the proper machine on site, you can move things around. Forms, as you can see right here, are always labor intensive. That's just a characteristic of formwork. And so you're always going to have a lot of folks on the site to be able to put forms up and take them down. And of course, then you're going to have your concrete forming crew in between. One of the things that we've talked a bit about is that concrete forms, they hold the concrete in the shape and size that you want, but also it allows you to be able to set up the rest of your design. Put your rebar in the proper place, set it up so that when you are done, you have the proper reinforced concrete. In other words, you got proper cover. The bar is located in the concrete in the proper location so that structurally it works. Okay, and that's one of the biggest errors you see, especially if you look at a lot of flat work, but it happens certainly on vertical work. But a lot of flat work, you see concrete and you see the reinforcing bars aren't being held in place properly. They move around. You see wire mesh, which can be an equivalent to reinforcing bars, being used and being moved around, not held in place, and being kicked into place. Well, you don't have the mesh located where it belongs to structurally support the concrete and take the loads that it's designed to take, and so it's almost a waste when you don't place the bars and hold them in place and support them during the concrete placing operations. It's very important. You see, by the little pie chart, that it talks a bit about cost, and the labor cost and the formwork material cost are a big part of the cost, and so you want to make sure your formwork is proper and again is economical to design. You don't want to over design your formwork at all. So again, what do we want in terms of